all of you are aware that there are these basic data storage platforms called databases, right? All of you have heard of databases. So typically businesses work on what is known as databases, right? They store transactions in databases. They store any kind of models about organizations in databases. They store all kinds of descriptions about, any entity which you want to model in databases. And ever since Cord, Turing Award winner, invented relational databases in 1980, the world has taken to relational databases, and companies like IBM, Oracle, and Microsoft and all milking millions or billions out of the invention of relational database. It is the mainstay today of any data storage, right? What's a relational database? It's basically like an Excel sheet, right? There are columns. Each column has a name and there are several rows. And by first normal form, you cannot have duplicate entries in each row column combination. So that's a relational database. That's where we have started our whole journey of business data. Business data today majoritarily resides in so-called relational databases, right? That's what it is. When you open an Excel sheet, you expect such kind of a data, or you open an Oracle database, you expect that. And coupled with that, we also have a mechanism by which you can query the language, right? You can query the data, which is what we have frameworks like SQL, which says, okay, select some rows from this data which satisfy some properties, and from multiple databases. If you have common fields, join them both, get me the aggregated data and get me the selected rows. That is what was the conventional view of accessing data via what is known as schema. So the data structure, which is the first row of the Excel, which is the column names, right? That is what is called the schema, right? The schema of the database. Schema of the database is the signature of the database. So what happens in IoT database? When you start seeing a stream of data coming in, there is just one straight stream of data. There is not like multiple columns, or you're not talking about multiple kinds of data types. You're talking about one uniform data coming in. That's whether it's a temperature stream or whether it is a stream of air conditioning output, or it's whether there is a stream corresponding to some tensile stress in a machinery which is being monitored for tensile stress. I can name it zillion IoT scenarios. It's going to be a single stream of data continually coming, right? And that's the challenge. The challenge is why the schema oriented structure called relational database, which was working for so many years, 30 plus, 40 years, zillions of transactions being stored in banks, in government databases, in databases which are working so long, how come they are not being able to handle the schemaless or the data coming in IoT? The answer lies in a very interesting universal law called CAP theorem, C-A-P. This is a very fundamental theorem in distributed databases in computer science, which says a very simple thing. If you want to look at three requirements for any distributed system: consistency, availability, and partition tolerance. I'll explain to you a little bit background. Then you need to make sure that you cannot guarantee all three at the same time. You can only guarantee two of them at the same time. When you say two of them at the same time, let me give you what a bank with an RDBMS usually does. A bank says, for me, consistency is more important. So what consistency means? If I am updating my bank account, everybody should see the same bank balance at the end of it, right? That's the basic requirement for consistent transaction. Whereas, how is it achieved? It is achieved by means of what is known as locking. If you are updating your record, you are given an exclusive lock to that part of the data where nobody else can get access to that. You have exclusive right to it, and then only when you update it, you release the lock, and everyone else gets to access the data, right? Now, let me come back to the scenario of a stream of data. Let's say in a social media context, there's a simple concept like a timeline for me is basically continuous monitoring of all my friends' pages and feeding into my timeline, right? I get continuous feed. To make it funny and interesting, let me give you a scenario of if I treat my Facebook page as a bank transaction, and if I'm updating my Facebook page, it is like my account. I'm updating my Facebook page. All my 500 friends, their accounts will be locked. They will not see their status being updated. They will just be locked. They will be hanging. Because in a bank, that's what I would be doing, right? Do you want to do that in IoT scenario or in a streaming scenario? No, that's the way the schema choice you have to make. Do you want consistency or you want availability? Availability is important in streaming data. Availability is important in high performance, low latency distributed data systems, whether it is in social media systems or IoT systems. That is where the schemaless challenge has been thrown to engineers, and they said, I don't want the strict transactional requirement which relational databases provide, where they compromise other aspects but guarantee consistency. So then we got this whole new generation of what we call as schemaless databases. That's where new kinds of databases have started emerging. Some are just plain key value pairs. I don't have any semantics, no Excel column value or key value, nothing. Or just have a collection of X equal to Y. Collection of this, that becomes my database. That's what is currently being used by almost all the distributed systems which need very low latency. And believe me, wherever you're talking about AI systems and analytics workloads, they're not worried about transactions. They're worried about information retrieval. They're only worried about building knowledge graphs, building analytics, building summaries, building aggregations, building ML on top of it. They're not worried about transactional integrity of what you're talking about. That's where schemaless databases are coming of age. They are the right choice, especially given the fact that IoT streams are typically with very high 2 V's, very high volume and very high velocity. That brings me the core of this topic as to why we think that schemaless databases are right for handling IoT. The reason is because we're talking about high velocity databases, it is very difficult to get that done in conventional relational databases where we're talking about transactional integrity and consistency of data being more important. But we have to relax this if we want to do IoT kind of scenarios. That is the first invention, or I would say, in fact, database researchers call it an invention. They say we're going back to very preliminary and unscientific data formats. But that's good because for me, availability is more important, not the consistency or transactions. That's good. So there's a huge debate between the RDBMS guys and the schemaless guys. But the IoT world, if you see, majority of them actually go into scenario where you do not want to lose data in the high velocity data that's coming in. So instead they use either a very highly resilient database platform like theirs, or they use reliable middleware which consistently, persistently stores in transient stores, etc. But none of them are so rigid or so transactional like RDBMS. So we have a MongoDB or a Cassandra or a Voldemort or HBase. These are the answers to the answer of holding data in an IoT context.